Hello, I'm Eric Snodgrass, and thank you for watching this Monday night in-depth ag forecast for January 16th, brought to you by Nutrien Ag Solutions. So I want to start off today having a quick discussion about two things I've been asked repeatedly over the last week or so. I've received numerous emails and also had just a lot of folks at different meetings I'm presenting at ask these two questions. So let's just address them really quickly. I'm going to play for you a video here. This was put out by NASA showing what happened a year ago. This was the Tonga eruption on January 15th, 2022. Remember that this particular eruption happened underwater. There was about, I think it was up to 400 meters of water above this that was vaporized by the volcanic eruption and then ejected deep into the stratosphere and even some of it into the mesosphere. So what was interesting was the initial study of this went into understanding if it put any sulfur dioxide into the atmosphere. And once that was determined that the amount of sulfur dioxide was quite low, it kind of had a lot of us back off on the potential climate impacts of this particular event. And it began to study what it did put into the atmosphere, which is a lot of water vapor. So we know that this particular volcanic eruption increased the stratospheric water vapor load by about 10%. And most of that over the following 3 months was removed from the system. It was precipitated out. But it did spread throughout most of the stratosphere. And normally when we think about having water vapor in the stratosphere, it does kind of have a warming effect in terms of what it might do to the radiation budget of Earth. And that's what most of the initial publications came out and explained. But when we think about this particular volcanic eruption, and I'm putting this in the context of some of these questions where people have been asking me if this volcanic eruption is going to cause in 2023 a kind of a 1 in 100 year drought event. There is no evidence for that at this point. There just isn't. And we also don't have precedent to make an assumption like that. So I just wanted to address that because that was the specific question that I was being asked. The other question I'm being asked has to do with something called the Gleissberg cycles. So you know that we have an 11-year cycle in sunspot activity. On top of that, there's a longer cycle. Some say it's around 90 years, some say it's 100 years. The idea here is that there's a second pattern to the sunspot cycle. Now, whenever we go from a peak in sunspot activity to a minimum in sunspot activity, the total amount of radiation, the total amount of energy that changes coming from the surface of the sun that the Earth will intercept is less than 2 watts per meter squared, and most times it's on the order of about a half a watt per meter squared. Now remember, any square meter that faces perpendicularly to the sun will receive somewhere around 1360 watts per meter squared. So we're looking at very, very tiny variations. And the question is that if we are right here, kind of near this solar minimum, even though we're starting to make our way, back up right now, is this going to have an implication on 2023 growing season? Again, the comment was that this was going to cause a 1 in 100 year drought to hit the midsection of the country. And again, I just have to say there's not evidence to support that. And I'm going to make a case for you real quickly here. First of all, our temperature and precipitation patterns do not follow this cycle. In other words, they don't go up and down with the sunspot cycle. It's probably a tertiary effect at best. What really controls our drought cycles, what controls our the length and duration of drought and heat waves has more to do with ocean temperature patterns that are the result of big changes in things like El Nino, La Nina, the PDO, the AMO. These are all big ocean circulation, atmospheric circulation, these coupled systems. And on top of that, it often has to do with just a loss of momentum in the summer jet stream pattern, which oftentimes is not predictable. I'll just tell you this. It's not just me looking at a graph and telling you something. I've actually taken all of the data, looking at the historical standard precipitation index data, the historical drought data. I have run several different statistical methods over it to try to understand if there is some sort of cyclical behavior to drought. And I'll be honest, I can't find one. And I'd love to find one. I mean, understand that. Because for me, pre-season, to be able to skillfully and accurately predict a drought event months in advance would be of tremendous value to the community. So it would be something that I would long to be able to find, but the data are not showing that. And again, you're just looking here for the United States at our standard precipitation index going back to 1895. In other words, I'm unable using statistical methods, even what I call poor man statistics, like just doing moving averages, I'm not able to statistically correlate our drought to any sort of cycle that is predictable, one, or to that Gleissberg cycle. So I just got asked that probably 30 times in the last week, and I just wanted to address it. So that just says that what's going to happen this upcoming summer is still something that is going to be something we have to discover and try to figure out. I'll give you some clues at least as to what we think might happen. We'll cover that again at the end of this video. Okay, so where we've been, let's just do a quick recap of this. The extended jet, we've talked a lot about this. This event is over. We have seen a change in the behavior of the pressure systems across Siberia. They've pushed up against the Himalayan mountains, and that started to rob momentum from this jet. But while it was on an incredibly fast right into the year. So looking at anomalous winds from the beginning of the year, this is where they were strongest, and they made the turn, and this is what just targeted this area of California into Nevada, and then even sometimes out into the plains with just a tremendous amount of water. So when we look back from the beginning of this year through the 15th, this is looking at these precip stat maps. Their precipitation ranks by climate district. I just get so hung up on these. I love these maps from Iowa State. You just see that main corridor that came right into this area, and many of these reporting districts having their wettest start to any year. As we've been discussing, drier north and south of it, and also some places along the Gulf Coast and East Coast. These are going to be areas that I think are going to be seeing relief. We might actually bring some moisture into the southern plains and along the coast here, and then into the northern plains out of the Canadian prairie as well. But the most important thing right now is just to look here at some infrared satellite imagery from the day on Monday, getting into Monday night. And what we don't see is what's important. There are no longer any huge lows stacked up into the Gulf of Alaska or the open Pacific that will be making their way toward the West Coast. So we're going to be seeing a drier signal, especially for California going forward. Now, just thinking about that, let's just kind of take stock of what this recent precipitation event did. I've been talking a lot about Lake Oroville. It's a huge reservoir in the northern part of the state, and right now it is over 100% of its historical average for this date of the year. It's at 56% full pool. Shasta's making major increases as well, and you can pause the video and have a look at some of the other reservoirs. These were incredibly important rainfall events. In the Central Valley, I just went to my my own forecasting system here where I give you all the different model data plus historical data. I just chose Merced, California. And what's interesting here is that a normal full year here in Merced would have something around 14 inches of precipitation. So already they've received more than half of their annual precipitation with just this event here since the start of the new year. So incredible to see that. I also want to show you just for California and Nevada, that's what this particular website is for, what we currently see right now in terms of snow water equivalent. And this is in percentages here. So it's just kind of using the colors to kind of tell us where we stand in terms of normal. But let's come down here and let's make this, I already did this. This is now the percent of April. So here is the current percentages. There you go. So this is as of this date, and these numbers, apologize there. Some of these numbers are just incredibly high, 200 to 300% in some places. But if we look at what these numbers are compared to April 1st, which is the most important date, thinking about the water year coming up, we're actually above those values for a lot of places here. So this has been an incredibly important event. And I've been showing you Oroville a lot, but I want to also show you Lake Shasta, because Lake Shasta has come up since it reached its bottom here. Take a look at this top line of around 916 feet. It is now up to 975 feet. So Oroville's come up about 120 feet. We've now seen Shasta come up here, 60 feet. I mean, the amount of water getting into the reservoirs is just incredible. Where we need to see improvement is in the southern Rockies, here in parts of Montana, throughout the Pacific Northwest. These are areas that we need to see the jet stream return better flow to see more moisture get into those spots. And one of the reasons I'm really concerned about Montana is because of this. You see, since the beginning of the year, it's been quite mild. Now, of course, we've seen near record warmth from Texas through the Midwest and the Great Lakes states and into New England. But I'm thinking again about the West, because the very mild conditions that we've seen here, plus the downslope warm, dry flow that's been coming over the Rocky Mountains, has actually melted the snow in this area. So we no longer have snowpack in an area that typically has a lot of snowpack. And remember, this area back at the end of 2022 spent about 8 days with an average temperature 40 degrees below the normal temperature. So it was just incredibly cold there. So this is something that needs to be filled in. This will be critical for this part of the Canadian Prairie, Montana, getting into the high plains here for the upcoming season to get the moisture back into place there. So let's look at it one last way here before I show you the drought information I'd like to show you today. And this just looks at the last 30 days in terms of percent of normal precipitation. We covered this in this morning's report, but I just want to make a point that this upcoming pattern shift is going to change things for parts of the southern plains. We're going to see increased precipitation chances for much of the southeast to the mid-Atlantic and the Midwest. We're going to start to fill in some of these holes north. There will be a holdout pretty far to the west down here, and the farthest south you go to Texas. That's going to be an area that's going to show up drier. But we need to keep a very close eye on how this upcoming pattern is going to alter this map. Now, with all of that, I just wanted to bring you to a drought monitor map and show you the class change we've seen in the last 4 weeks. So this just kind of shows us where we've been for the last couple weeks of December and the first 2 of January. And you do see a lot of improvement. And as we talked about last week's video, we've seen a 20% reduction in total land area across the United States, or the lower 48, in any form of drought. And very few places have increased in their, or had a degradation in their drought picture. Okay, so what have we seen lately? Well, this is the last 72 hours. So the last of these systems has come into the west. It's moving over the Four Corner states now. Out ahead of it today, there was a tight low that spun up here into parts of Iowa. And we were watching this one very carefully. Let me play this for you. Because in this low, there was so much wind shear that right in through there, see that complex of storms? We just pause this and take it back there again. It was that complex of storms right here that actually produced a series of very photogenic tornadoes. I'm sure a lot of you saw them in news or saw them on Twitter today. And this was our concern this morning, that we could see something like that happening. So what do we have now? Well, we have winter weather advisories north of that system, but the next one coming out of the Four Corner states, which again was the last one to come through California, has now got a large area of winter storm watches here and winter storm warnings in parts of Nebraska. And this one will also give us the risk of some strong storms farther to the south on Wednesday. So the Storm Prediction Center, I'll be looking forward to tomorrow's update of this to see if they change this. But from eastern Texas through Louisiana, southern Arkansas, and western Mississippi, they've got a slight risk out for that time period. So let's go right on into the high-res NAM. I'm recording this about 11 o'clock Central Time on Monday, so that's where I'm going to pick things up. So here's the low that earlier today produced those tornadoes in Iowa and the heavier rains out ahead of this. And this is the next low we're going to watch behind it. So let's play it forward going into early Tuesday morning as this spins out over the Great Lakes. The main upper level front will then push over the Appalachian Mountains, bringing some showers and maybe some embedded storms into the Carolinas, out of Virginia, all the way back down here to Alabama. So that system clears east, and then the next system begins to emerge out of Colorado. We're going to see potentially some heavy snow here, like Denver metro area north, getting into Nebraska. This is early in the morning on Wednesday, playing through mid-Wednesday here. Stop this at noon. We're going to be on the lookout for the potential for some ice, like in and around I-80 from like Omaha to Lincoln and into this part of southern Iowa, And then we're going to watch on the front to the south where we have the risk for those strong storms again. So this low, as it curls through, will be delivering quite a bit of snowfall here into this area. We'll take a look at the snowfall totals in a second. But this particular animation will go out to Thursday at 6 a.m. as it's spreading snow through Iowa, Minnesota, and Wisconsin, with the risk of some ice out ahead of this. All right. Now, you did see there was another system that came into the Pacific Northwest. See it there? But this front is attached to a low that's no longer hitting California, but way up in British Columbia. And it's going to come in and hit the I-5 corridor, put some snow on the Sierra Nevada mountains. This is midday Wednesday. And then going to push into the interior right in through here with some snow showers. Okay. So from there, I want to just get back to the bigger picture things that are going to change. Then we'll do the multi-model analysis. So as we play this forward, this is looking down on the North Pole at jet stream level winds. The jet stream retraction event we've been talking about will fully manifest itself by the middle of this week. You see that we get this fast piece of the jet stream, but it fails to completely move across the whole of the Pacific Ocean. We kind of break the flow up into something like this. So that means troughs will be digging in this area, which is what we're going to have to watch next, and then picking up on this subtropical jet racing off to the east. But we see that pattern sticking around through this weekend into the middle of next week and even beyond that. Now, what is very interesting about this, and this is something I'm kind of just watching carefully, is that the models have increased the speed of the winds here. And that is a component of the subtropical jet which fully manifests itself there that we haven't seen during winter in a long time. It's not common during a La Niña to see this. So to see the models picking up on that at the end of the month, it's going to be important to understand how deep the cold air can get in, because this is mild air here, and then how strong this subtropical ridge is in the southeast to really force this air to exit quickly, and what that might do to the precipitation patterns east. So with that, let's go to the models. GFS 12Z on the left, our European 12Z on the right. So we've already seen through this point on Wednesday. So let's park it right out here. So you notice both models putting down snow almost in the exact same locations. We have the risk for the severe storms right in through this area on Wednesday night. It's in both models here. As we play forward through the day on Thursday morning, afternoon, and evening, this low spreads east. The snow comes with it here through the Great Lakes states, and then that one's going to pull into New England, possibly delivering some heavier snow into the interior of New England. Again, this pattern is not set up to give us those like Miller B storms or to get something come out like this. At least it's not right now. We notice that the next system that comes into British Columbia does bring a front here on Saturday into parts of the Pacific Northwest, but our attention at this point will go to the fact that a deeper trough will be here, and it might kick off a low into Texas. It will have no trouble drawing in Gulf moisture, so you're going to watch for possibly this upcoming Saturday night for strong storms along the Gulf Coast. But there'll be some cold air on the backside of this low, and therefore we're going to be on the lookout for maybe some mixed precip here next Saturday night. So you see that low coming out here. Now the models do split at this point on what they're going to do with this system. Notice how I've been rocking back and forth over Saturday and Sunday. The GFS aggressive on unloading a low that kind of comes up and puts more snow into this region. The European's not seeing that, keeps it farther to the south, and then spreads its precipitation along the coast here, delivering some snow to the eastern Corn Belt. But notice that behind that, there's another low that kicks off. And this whole pattern shift is going to start to deliver systems that do this rather than what we saw, which is that. Okay? So we worked our way out through a week here in terms of precip, but let's kind of dial this back and see some of the numbers. First, I'm going to take you to the WPC 72-hour probability of snowfall. You're looking at the chance of getting 4 inches, so very high probability over the next 3 days in this area. Let's step it up to the chance of getting 8 inches. This is where our highest area is, up to 70% chance of getting 8 inches there. And over a foot, again, we're going to keep an eye on this same area. Now, when you look at the operational runs, so this is today's 12Z European model, here starts spreading the snow out of Colorado early in the morning on Wednesday, and then into Nebraska, Iowa, Minnesota, Wisconsin, and through parts of northern lower Michigan and most of the UP here. So that is the first event that's coming through. Now, I'm hesitant to keep playing this beyond this because today's operational run also wants early next week to drop a system way down here into Oklahoma and Kansas. Now, we don't know if this is going to fully manifest itself. There's very little ensemble support for that at this point. So let's just park it right here and see the depth of the snow as forecast by the current European model. All right. I also want to show you the probabilities here of getting certain amounts of snow. So this is over the next 10 days, probability of getting 3 inches. Here it is for 6. There it is for 12, and again, watch right in through there for the highest potential for the heaviest snow, and then interior parts of New England. So I don't want to feel like I'm ignoring this up here, but there's also very heavy snow in the interior parts of New England and around the Great Lakes as well. From here, why don't we flip this over to look at the precipitation side of it and look at the probability of getting at least an inch out of this. So the 10-day probability of an inch is quite heavy down here from the lower Mississippi River Valley into the southeast, pushing into the Tennessee and Ohio valleys. That's where we're going to see the best chances of picking up quite a bit of wet weather. And who stays dry, we can flip this over to say who's got the probability of getting less than 1/10 of an inch. And what's important is that the models have peeled back on the risk of being very dry in this area because of this new pattern change with the flows coming in a bit more like this. So that leads me into week 2. And while the West Coast is drier than normal for this time of year, and remember, this is usually some of the wettest time of year here, that split flow making things drier, We've seen a return toward normal precipitation here, better chances of systems diving down, and the whole of the East Coast sees better chances of rainfall as well as we go into that end of January time period. So that's what the last week of January is going to look like. On the temperature side of it, Tuesday's high temperature is still very hot out in the warm sector of this system here. The front did not clear enough to really make this quite cold. Then we go into Wednesday and Thursday of this week, very mild again in the eastern Corn Belt here. And then as we get into Friday, Saturday, and Sunday, this is where the pattern starts to show up with a change. Both the European and the GFS model, when we look out there day 5 through 10, are starting to clear more of this mild air east. What will be the determining factor on how long this sticks around is the size of this subtropical ridge down here and how quickly the jet moves through it. So the faster that jet moves, the better the chances of more mild conditions here, with the colder air coming on the backside. So this is day 5 through 10, and this gets you right up to the end of January. That's when we start to see more high latitude blocking, and we start to get some colder air that comes back into the Canadian Prairie, Western United States, Northern Plains, Midwest. So we're going to certainly see better chances of this colder air returning to a big section of the middle of this country, or the middle of the continent as we go into February. The complicating factor with this, as we've been talking about for a while here, is that we are predicting that by the time we get into Wednesday and Thursday of this week, you see these two large stratospheric ridging events. Okay, so this is warming here, splitting the polar vortex up into two pieces. That's a sizable disruption, and it seems to continue to force the polar vortex into a disrupted state all the way through the end of January. Now, where and when it finally connects with the tropospheric trough event to deliver a lot of cold air, that's still not known yet. It sometimes can take 2 to 3 weeks for this to manifest itself. What I'm saying, though, is that this is another signal for the potential for cold air intrusions as we go into the month of February. So let's talk about February. The newest ECMWF was just released, and it has gone back into what I would consider kind of a really La Niña look. Wetter in the northwest, systems turning here. So we're drier in California. There's risk of being drier in western Texas, but very active here. Tennessee, Ohio, Mid-South, this whole region over here along the Appalachian Mountains. So I can buy this because I know what the La Niña is doing, and this is a very La Niña look. It also makes sense to see that the temperature forecast for that time period is showing greater risk of seeing more colder conditions with time. Now, I keep talking about La Niña. Let me show you why I think this is a major component. This goes back to October, and I want you to see that even though the La Niña is weakening, okay, watch here. This is now getting through November, and watch into December. Watch right in through here. This is all starting to fade. Even though the La Niña is still present, it is fading, but it still has some sort of control on the pattern, which means we are still predicting a weakening of this La Niña to continue through spring. We can also see some evidence here that the warmer water at depth is beginning to surface over here, eliminating some of the cold anomalies. That's why over here, Niña region 1.2 or 1+2, that's right up next to South America, starting to show some warmer conditions. So I say, though, that La Niña is still an actor, and it's because we still have strong trades right now. They've come back. There's even some hint that maybe by the end of this month, a bit of a westerly wind burst. So this isn't going to lock the MJO into place, but it is going to keep it probably somewhere in this vicinity, not letting it come out way over here into the Pacific, but probably keeping it in this general area with time. We also know that the Southern Oscillation Index is very high right now. And again, that is a consequence of the pressure patterns driving these winds, all right? And we know historically that if the Southern Oscillation Index is higher, that we tend to get this precipitation outlook for January and February. See, it tends to be wetter here and wetter there, and the blues actually represent drier conditions. And those are the two areas I'm worried about that are drier, here and here. I think this region is going to be wetter, though. It may only be southern Florida that sees the influence of that big subtropical ridge keeping them drier. I think we're going to see better chances for moisture returning to some of the drier parts of the southeast through the mid-Atlantic. Okay, that MJO, it is going to come out into the Indian Ocean very weakly here. And that's important to know because if it does make this move, it is likely that we'll continue to see this pattern. I've been showing it to you a lot the last couple weeks. Fast bit of the jet stream here, but likely a ridge between Hawaii and Alaska. So the flow is going to come in and exit like this. How far into the southeast this ridge extends will be the big question, but this is certainly lining up with the behavior in the tropics. That's what we're trying to stress here. So I'm just going to come back to it as a way of kind of capping this off. I'm buying into this temperature pattern and this precipitation pattern as we go forward into the month of February. It makes sense to me based upon the current global teleconnections. What could make me wrong? If we see any sense of high latitude blocking over Alaska, over Greenland, over Scandinavia, one of those areas, it will amplify the pattern and change this up. And that's always a possibility. So I want you to know that I'm watching Alaska, Greenland, and I'm watching the Scandinavian region for a major blocking ridge event that could upset this pattern. To finish this up, I'd like to talk quickly about South America. In Argentina, we know that the last month has been quite dry with limited thunderstorm activity delivering rainfall. So the SPI for December 11 to January 10th shows several regions, very productive regions, that have been extremely dry during that time period. When looking at a global vegetation health index map and comparing it to last year, you can see that there's a lot of this same area down through here that's shown a major degradation compared to a year ago. From there, I want to show you what I think is going to change. We have seen since back in September that the Antarctic oscillation has been positive for the most part. And when it's positive, Argentina runs a greater risk of being drier. Well, the latest forecast is suggesting a bit of a breakdown in this. And the timing of that breakdown could correspond to later on this week when we see this. This is the 12Z model run. Heavy rains through parts of central Brazil, normal rains up near Mato Grosso. But you can see here by Thursday, or actually Wednesday, some of the rains coming in right in through here, such that by Friday into Saturday and Sunday, this front's going to swipe through and start to deliver better chances of weekend rains. And that's been some of the best chances we've seen of rains in a long time for Argentina. So let's use this and add on the ensembles to kind of get an idea. This is a 5-day window, so this is day 2 to day 7. So this ends on next Monday. And as we play this forward, we will see here that getting out there around day 10, day 5 through 10, then day 10 through 15, the models have continued to be more aggressive on returning better moisture to Argentina, keeping the high moisture values here in central Brazil, and where they're harvesting right now in Mato Grosso, near normal with a slight dry bias overall. So that's going to be very important to watch. But these rains coming in through here could be quite important for stopping the damage from the drought and possibly improving some of the quality of the crop there. So I appreciate giving me some extra time tonight as we talked about some important factors at the beginning and some of the big things changing. I'll talk to some of you that get my report again in the morning, and for everyone else on Thursday. Appreciate it. Thanks.